Assalamu alaikum dear viewers, Shoaib and Dayo is here with the new lecture of the electrical machines, and today we are going to solve the EMF equation of a DC machine, and the DC machine can be act as a DC generator or the DC motor. Recall the concepts of the DC machine construction. It comprises of the 5 essential parts. Number first is that the field system, second is that armature conductors, armature core, a commutator and the carbon bushes, and there are the two main essential or the major parts of the DC machine. The field winding is used to create the necessary MMF and also used for the creation of the magnetic field within the field winding conductors. And in the armature winding is the rotating part of the DC machine in which the working EMF is produced. In the case of the DC generator, the generated EMF is produced in the armature winding, and in the case of the DC motor, the back EMF is produced or the counter EMF is produced in the armature winding, which opposes the applied voltage. So now let us solve the EMF equation of the DC machine. So number first is that phi is the magnetic flux per pole in Webers. So the unit of the flux is Weber. Second is Z is the number of armature conductors, okay, and then P is the number of poles. Now, okay, so phi is the magnetic flux per pole in the Webers, Z is the number of the armature conductors, that will be the we can say that the total number of the armature conductors, P is the number of the poles, and then the A is the number of parallel paths. So this value of A is equal to the 2 for the wave wound DC machine, and this value of A is equal to the P for lap wound DC machine. And then EG, so EG here is the generated EMF or EMF generator, EMF in the generator, or EMF per parallel path, okay. Now the first is that according to the Faraday's law of electromagnetic induction, whenever a flux is linking with the coil is changes, an EMF is induced in the coil, so that will be the d phi over dt. So magnetic flux cut by one conductor in one revolution is d phi is equal to p phi. So in this will be in the terms of Webers. Flux unit is the Weber. Then the time taken to complete one revolution, time taken like by armature conductors to complete one revolution, so this will be dt, that will be 60 divided by n in seconds, okay. Then EMF generated per conductor. EMF generated per conductor is the, according to the Faraday's law, d phi over dt, the rate of change of flux with respect to the time. So we have the value of the d phi is the p phi over here in the above equation, and what is the value of dt over here? It is the 60 divided by n. So by simplify, this will be phi np divided by 60. So EMF generated per conductor is the phi np divided by 60. Now EMF in generator are like EMF generated in armature conductors, okay, is equal to the EMF, okay, generated per parallel path. EMF generated per parallel path. So this can be, is going to be EMF per conductor, means this Eg, generated EMF per conductor, multiplied by the number of conductors in series per parallel path. Marker, okay. So EMF per conductor multiplied by number of the conductors in series per parallel path. So EMF generated per conductor, what is that? Phi np divided by 60. We have the value phi np divided by 60, okay, and this number of the conductors in series per parallel path is the Z divided by A. So here this Z shows the total number of the armature conductors, and A is the number of the parallel paths, as already we have shown in the data. The A is equal to the 2 for the wave wound DC machine, and A is equal to the P for the lap wound DC machine. So by simplifying, we get phi NZP over 60A is the EMF generated in armature, which is the Eg. So this is the final EMF equation of the DC generator. We get that is the phi NZP over 60A. So Eg is the generated EMF. Now let us discuss some points related to the EMF equation. Number first point is that in the case of DC generator, okay, in the case of the DC generator, so this will be the Eg, this will be Eg, so it is called as the generated EMF, denoted as the Eg in armature conductors. Now, in the case of DC motor, so it is called as the counter EMF or back EMF produced in the armature conductors. So now this, in the case of this DC motor, this EB, which is the back EMF or the counter EMF, is always opposite the applied voltage to the DC motor. So now what will be the EMF equation in the case of the DC motor? Same, but instead of writing over here the EG in the case of the DC motor, we are going to write over here EB, which is the back EMF, is the same one, PɸNZP over 60A. So in the case of the DC generator and in the case of the DC motor, so this will be in the case of the DC motor, and EG is equal to the PɸNZP over 60A in the case of the DC generator. Okay. Now from this equation, some parameters are constant, which the P is the number of the poles, okay, the A number of the parallel paths, either the lap wound generator, it shows if the value of the A is equal to the 2, so this will show as the wave wound generator, wave wound DC machine, and if the value of the A is equal to the P, so this will be called as the lap wound DC machine. PAN, then the Z. So the Z is the total number of the armature conductors, okay. So these are three parameters or the constants, but our generated EMF, or in the case of the back EMF in the case of the DC motor, or generated EMF in the case of the DC generator. Take an example, in the case of DC machine, now in the case of DC machine, either it is DC generator or DC motor, okay. Now this EB or EG, maybe with this EG or EB is directly proportional to the magnetic flux per pole, magnetic flux per pole, and the number of RPMs or the speed of the armature, or the number of the RPMs of the armature of the DC machine. So dear viewers, this was the EMF equation of the DC machine, which we have solved step by step on the board, Okay. Now let us solve the problem or the numerical related to the EMF equation of the DC generator. So the example is, calculate the EMF generated by the 4-pole wave wound armature having 45 slots with 18 conductors per slot. We have a 45 slots and the per slots are the 18 conductors driven at the 1200 rpm and the flux per pole is 0.016 Weber. Now what we have to calculate? We have to calculate the generated EMF in the wave wound generator. Now let us solve the problem. First of all, we need to write the data. We need to write the data. What we have given, the P is the 4, P is the number of the poles and number of poles are the 4. Okay. Now this is the wave wound DC generator. So in the case of the wave wound DC generator, the number of parallel paths, A value of the A is equal to the 2. Okay. And we have to calculate the total number of the armature conductors. So we have 45 slots and 18 conductors per slot. So the total number of the armature conductors Z, so that will be the multiplication of the total number of the slots and the total number or the number of the conductors per slot. So number of conductors per slot are the 18 and the 45 are the total slots. So that will be 810 conductors. Okay. So the total number of the armature conductors are 810 conductors. Okay. And then what is the value of the N, which is the RPM? So that will be the 1200 RPM. And what is the value of the flux? So this will be 0.016 Weber. So what we have to find out? The Eg, which is the generated EMF. Now the solution of the problem is very simple. By writing over here the EMF equation of the DC generator PɸNZP over 60A. So put the values of the parameters in this equation. So the phi is the 0.016, value of the N is the 1200, and then Z is the 810, and P, the number of the poles are the 4. Okay. And 60 multiplied by what is the value of the A in the case of the wave wound generator? Is that is a 2. So by solving this we will get the 518.4 volts. So this is the EMF which is generated, or the working EMF is generated in the armature conductors in the case of the wave wound DC generator. So dear viewers, this was the lecture related to the EMF equation of the DC machine, in which we have solved the EMF equation of the DC machine. Either it can be act as a generator or act as a motor, and that was the PɸNZP over 60A. So this was the EMF equation of the DC generator, and also we have solved the numerical, simple numerical, which is related to the EMF equation of the DC generator, to just understand or to recall the EMF equation of the DC generator. And this was the lecture. I hope that you have enjoyed today's lecture, and I hope that this lecture is very informative for you all. And at the last, do subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering area. Thank you.